Welcome. I'm Tom DeRose, Executive Director of Creation Studies Institute. We're beginning our first series on Dismantling the Theory of Evolution. Part one, we're going to be talking about dismantling evolution from the beginning. And I really feel that this is a very essential part of what we're going to be addressing. Now, I don't know about you, but when I went off to college, there were a lot of questions in my mind. I went to a seminary and was well trained on religious training, but there are certain things that came to me that challenged me. And you might say, how do we get here? That's pretty easy to answer if you believe in the Bible, right? I believed in God, I believed in the Bible, but when I went to the university, I became open-minded. I said, well, these guys know a lot, right? They're going to tell me how did I get here? And even though, I had these religious tendencies, they were literally bombarding me with, how did I get here? They also told me, where did everything come from? They told me, they answered that question. Where did everything come from? And so that's what we see in the textbooks. It's not just in college, it's from elementary all the way up. This is what we hear. This is what we see today, that they're telling us how we got there and where everything came from. Now, this little pug looks confused. Well, I was very confused at one time. And I didn't know, there were a lot of things going on in my mind. And I was at an age where I was experiencing things and I wanted to just try, I don't know, I just want to try things. And before you know it, I got this kind of idea that maybe naturalism was a reality. And so I'm going to describe naturalism because I think as we talk about dismantling evolution, we need to understand what this whole thing is all about. And it's going to come down to kind of a philosophical discussion in the beginning, but I need you to understand it. Now, when I talk about naturalism in theater, film, and art and literature, they talk about it a little differently. They believe that it was very recent, originated in the 19th century. They believe that it seeks to portray common values of the ordinary individual. And they also subscribe to the outgrowth of this kind of realism, which centered on the inner soul, inner self. So that's what naturalism kind of is in the literature sense, in the film and art sense. So the word naturalism, in this case, is not what I'm talking about. I'm talking about the philosophical naturalism. And that contains basically this. It embodies matter, nature as the ultimate reality. Now, I know we're going to be dismantling evolution, but you need to know about naturalism because this is the key factor that's going around in our schools and educational systems. Now, when we talk about being embodied by matter, that is where everything resides. Nature is also a force that has the ability to change through time. So nature develops characteristics. These characteristics are characteristics we might recognize as somebody living, but in this case, nature's power is literally to change things over time. And it's interesting because nature is indifferent and moves independently. So nature doesn't, have a soft side or a weak side. It just moves. It just moves and it moves independently. This is what they believe in. This is naturalism. And so when you say forces, maybe forces of evolution, forces of nature, they believe that there are forces there and they're dynamic and they're ever going. More time, nature becomes all powerful. And I've seen this over and over again. I have a beautiful quote that I use. Actually, let me read over here. Let me just take this little card here and read this to you. I took this picture from the field, the Chicago Field Museum of Natural History. And it says here, time is unimportant and never difficult for nature. It is always at her disposal and represents an unlimited power in which she accomplishes her greatest and smallest tasks. Notice, time is unimportant, never difficult for nature. Notice how that tie in? Now, this is Lamarck, and he's credited for one of the founders of evolutionary theory. He came before Darwin. So he's talking about nature having power. And the more time you have, the more power it can have, it can possess. So now, where does science fit in? Well, naturalism and scientism. Scientism means you can find truth in science. Naturalism means we can find truth in nature or whatever. And so basically, it's governed by natural laws because nature, ready for this, has the properties of regularity, predictability, and unity within. Something we know about. We know about the sun rising in the morning, setting in the evening, right? We know about the stars coming up at night. We know that there's regularity. It's all over the place, that nature is regular. So they look at it and say, see, it has its own laws. It's governed by its own laws. So nature can be studied objectively and scientifically. And so there's a parallelism, a direct parallelism between naturalism, and scientism. And today, science is defined as finding the truth in the natural phenomena. In other words, finding the truth in what we have here. Nothing is allowed outside the box. You follow me? It's not scientific if you even talk about an outside force coming in. You don't have to mention God, just an outside force. That's not scientific. That's pseudoscience. That's what they call it all the time. So creationists are part of the pseudoscientific mode. We're pseudoscientists because we participate in this kind of out of the box kind of thing. You see, when we look at this, we see that the universe, literally, when we look up at the sky, we can see that the sun, and we can see the earth, and the earth goes around an elliptic plane of the earth's orbit around the sun, and that literally never changes. Now, you can see the stars, and you can see where they are. Now, there is some change, but they're there. And so every year, we get this kind of rotation, and we can see the stars, and we can see where they are. And people have developed, this is called the queen of science, they developed lots of theories about stars. I mean, it's where science began. And what's interesting is that you can take this kind of wheel, this elliptic that we're looking at, and rotate it backwards in time. And you can get an idea of what Jesus Christ might have experienced or what Caesar might have experienced, because this is very reliable. You can take this where these stars are, and move it back in time. So let's define evolution. Now, evolution is defined. I'm going to give you, I'll read off my notes here, but I'm just going to do it briefly. Evolution theory is in biology postulating the various types, plants, animals, and so on, and living things on Earth. They originated from pre-existing types. So looking at evolution, they're saying that we come from pre-existing types. In other words, there's going to be change through time. There's going to be development through time. And it's going to be something where we're going to take from the simple to get to more complex. And that's basically a very simple idea, change through time. And there's always an upward change. So we have the idea of cosmic evolution. Cosmic evolution means what? It means that there was an explosion, or somewhere there was a high order of space, and at that particular was a particular point in time where that thing exploded. And when it exploded, out all the energies necessary to cool it and give the stars we see today and the universe we see today. So from that kind of perfect unity, as it exploded, we were able to develop over the years. Now it's 13.8 billion years ago. So over the years, we're able to see this kind of ever developing system occurring. And they look at star clusters, they look at areas and say, there's a new star being born. Now, I must remind you that nobody's ever seen a star being born. They have ideas of stars being born, okay? So, I mean, this kind of concepts and ideas we fool with, but we deal with the present. And whenever we deal with these evolution, we're always dealing with the past. Biological evolution says that, well, we came from, materials within, and eventually we became what we are today. So it's always an upward change, always moving up in some degree, always getting more and more organized, supposedly, and then disorganized, organized, disorganized, and going through a system where eventually the best shall survive, using Darwin's survival of the fittest. So we do have a controversy. Why is the controversy? Well, evolution and creationism don't get along. Evolutionism speaks of everything going together, coming together by randomness and so on. And when we look at evolution, they say nature is the one who did it. Nature. So we see nature being part of that. Now, so nature and its laws, and then we see God and his word. So the idea that nature is what made us, okay, what caused us to be who we are, versus what God and his word makes us. So there is a controversy, you see, a big controversy there. So our kids are being taught basically in public schools, even in a lot of the Christian schools, they don't have an idea what, you still go with the Big Bang and all this, and they're thinking that we were created by that. Okay, so what kind of mechanism, how did this take place? And that's the key. How did it take place? Now let's go to nature. We know nature and its forces. What do we know about it? Well, we know that there's a lot of randomness. There is like chance happenings that occur, and you could be lucky to get how we are today. Many scientists have said that, hey, we're lucky. We're just lucky to be where we are today. Crick, the co-founder of DNA, said that it's a miracle that we're alive today. It's a miracle. And then, of course, it's by accident. Now, that's what they suggest. I didn't say that. That's what I read. That's what they've been telling me over the years. Now, we can scientifically call randomness, statistically, and throw around the statistics and all that. Bottom line is that randomness doesn't have any purpose. And that's what we see in God and his word. We see purpose. We see intelligence. Chance, randomness goes against intelligence. What intelligence does, it gets around the randomness and chance. Think about it. We're always going and getting rid of this idea of chance and randomness and so on. I'm reading a book on Thomas Edison. He was an atheist, a declared atheist. He had so many patterns, a genius in his time. And he was always going against this randomness, this chance. His inventions had to be specific, and more specific he was. He spent hours in the lab just getting everything perfect. And so you get the idea that he was going against what he was believing in, because there was intelligence and purpose behind everything he did. There was, of course, design and planning. So when we look at nature, there's no outside influence whatsoever. Evolution, nature. Nature gets the credit. When we look at God and his word, we see outside influence, and we see God gets the credit. A big, big, big difference, okay? So that's where we see conflict all the time. Who gets the credit? Does nature or does God? Now, I need to tell you that it's been very popularized, and one of the people that made evolution so popular is Richard Dawkins, popular evolutionist and atheist. He wrote a book, Selfish Gene, in 1977. It made him very popular. That's what started his career off, because he talked about this replicating molecule and how that nature would move selfishly and move on. And he kind of said it this way: at some point, a particular remarkable molecule was formed by accident. We call it the replicator. Now, this is from his book. I took it directly from this book, The Selfish Gene. He suggests that this replicator molecule is not necessarily the biggest or the most complex, but he imagined that this one could be replaced over deep time. In other words, millions and millions of years, eventually this replicator could have another replicator. And then you'd have another replicator. Before you know it, we'd have complexity. He goes on. He says, he went on and admitted that although this was highly improbable, possibly over hundreds of millions of years ago, it could happen as the chances of winning the lottery get better if you lived all those years. Yeah, you got to keep hoping. Because the more we study, the more we realize that it gets more problematic to be able to develop life from molecules. Very important to understand. Complexity of life overwhelms us. And that's what I'm going to be addressing, not tonight, but in the future. So as we go further, we take a look at the father of evolution, biological evolution, is Charles Darwin. And he said this in a writing to Hooker in a letter. He said, but if, oh, what a big if, we could conceive in some warm little pond where all sorts of ammonia and phosphoric salts, light, heat, electricity, and a present, that a protein compound was chemically formed, ready to undergo and go still more complex. And he went on and on. Notice he said, but if, oh, what a big if. And it's still a big if. Now, I kind of put this away thinking that, oh, you know, they did all these experiments. I think big people was, you know, Miller experiments or other experiments that were done in the past, all following these kind of things, which we're going to spend some time on next time around. Bottom line is that, and there were failures. Guess what? It's not ending. People are still, they're still trying to create man. The Frankenstein, it still exists. And you see this in Ventnor's work where he tried to make a replicate a molecule. Ventnor, with Francis Collins, exposed what DNA really is around 2000, 1999, 2000. But Ventnor took on a whole new venture where he tried to explain that he can make a replicate a molecule. He did it all right, but if you check how he did it, you'll see that it was highly improbable with natural conditions. So we see this. Now, I'm going to discuss this in much more detail next week, or next month as we do our seminars. We're going to dismantle evolution, and I want to do it from evolution from molecules and up. And we're going to be discussing things. What are origins of life? Is there a possibility that life can be discovered beyond the planet Earth? Do living forms contain information? What are current most popular topics taught to students about evolution in our schools today? And we will answer these questions and much more. So please keep in tune with us. We'll be doing this the last Friday of the month. And I hope we'll be exposing some interesting things. And I hope to have some guests to come along with me to go through this process. We'll have an unbelievable explanation of the fallacy, this terrible fallacy, how you can make life out of molecules. So, for some unknown reason, the Big Bang exploded. Did you know that? The Big Bang exploded for some unknown reason. It's a big mystery. This is one of the reasons why when we discuss nature and naturalism, the Big Bang cosmology certainly falls into this, doesn't it? Because all of a sudden we're talking about a phenomena that's never happened before. The fact that we have all the matter and energy all in one spot, and all of a sudden it exploded. It's without a known cause. See, Robert Jastrow, founder and former director of the Goddard Institute for Space Studies at NASA, wrote this: the universe and everything that has happened in it since the beginning of time are in a grand effect without, ready for this, a known cause. So all the cosmology you hear today about Big Bang, how it began. We have, okay, we're going to tell you how everything began. It came from a Big Bang. But how did the Big Bang start? We don't know. It exploded. We don't have any idea why it exploded. And cosmologists try to discuss this, and nobody has come up with a sufficient reason. But I want to tell you one thing. One thing I will tell you is that there had to be a great big force behind this, because that big force had to get everything moving. And when I see everything moving, I mean everything moving. You know, the Earth rotates on its axis 1,000 miles per hour. You got to get that thing moving. It stopped. You're traveling at 1,000 miles per hour. Now, you're traveling at that speed, but don't use that when a police officer stops you for speeding. You're speeding now in relative speed, but you're speeding. You just stop right now. The Earth stops. You're going 1,000 miles per hour. You never realize that. Yeah, I'm standing still. No, you're not. No. You see, not only is the Earth rotating around the axis, it's revolving around the sun. Yes, it's revolving at 66,000 miles per hour. That's like a speeding bullet. That's how fast it's going. 66,000 miles per hour, 30 times faster than a rifle bullet. So you're moving that fast. Seriously. I'm moving, yeah, you're moving 66,000 miles per hour. Actually, I have to take that back. The sun is moving at, and the solar system is moving at 514 miles per hour. Yeah, that means that literally you're not standing still. You are moving. I mean, really moving. You're moving with the solar system at 500,000 miles per hour. And guess what happens when you get to the galaxy? Yeah, our Milky Way galaxy. That's moving too. How fast? 1.1 million miles per hour. Now, I want you to think about that for a second. You're standing here on the Earth and you're like, I'm standing still. But in respect, you're not. You're moving at such a fantastic speed that you don't even realize it. Now, Einstein played with this a lot, the laws of relativity and all that. But it's amazing when we look at the universe and its complexity, and that it's moving at such rapid speeds and moving out. I mean, moving out with amazing amount of energy. So just by looking at the speeds of these objects can kind of bring you back to how much energy and force it would be needed to start this universe up. And then we look in terms of what we see. Well, we see planets, we see the sun. The sun is kicking out all the energy we need, plus much, much more. And then we have the planets, all having their certain characteristics, rings around Saturn and so on. Amazing when you look at it. And then when you look at this, when you look around here, you see that what happened here? Okay, there it is. The Big Bang produced all these heavenly bodies. Imagine that. The Big Bang proves all of this explosion literally produced the galaxies we see, the planets we see, the sun, and so on, all with amazing amount of organization. And so galaxies, stars, planets, meteors, all the heavenly objects. Did the universe with its order come from Big Bang that had no cause, or did they come from a divine watchmaker? Sir Isaac Newton, or Rene Descartes, declare that the answer in the statement, it says the physical laws he had uncovered, the physical laws he had uncovered reveal the mechanical perfection, the working the universe to be akin to that. So what are the forces to move the heavenly bodies? What are they? We have strong nuclear forces, weak nuclear forces. We have other forces. We have the weak nuclear forces, the forces that literally have the control radioactivity, the way the atoms move out, and so on. We have electromagnetic forces. These forces literally keep things together. We have the gravity forces. Now, the gravitational forces to me are amazing because that's what I see in the universe. I looked at today and I saw a full moon. That full moon is being, the gravity of that moon, that big center thing, tons and tons of mass going around the Earth because of gravity. And we look at the whole solar system, we see it's gravity doing it. And then we look at the galaxy, gravity is doing that. So gravity seems to be moving these masses of objects, massively. And yet it's the weakest force of all. Gravity is the weakest force. Nuclear forces, strong nuclear forces keep everything, that's the strongest. But they're not, those strong forces only exist in a short distance. Gravity can extend all the way out in the universe. So the universe and its heavenly bodies function as a fine-tuned machine. That's what Newton said. And so here's Isaac Newton. And you see him, getting hit by an apple. And then he comes up with the formula that I've taught my physics kids for many years. Now, he never got hit in the head with an apple, but he observed an apple falling and he realized that when the apple fell, it accelerated. It moved faster and faster and faster, just like you would, accelerate if you jumped into off a hill or whatever. You gravity pulls and gets faster and faster. That's how all rides are made. So we know that, but it's interesting. Newton took that force and he said that force controls everything. That G force on Earth is the same everywhere. And he even said to us that it had a constant. We found out later what the constant was. That number never changes. That number always stays the same. And because of the formula and because that number ever changes, you ever go and say, I wonder what I weigh on Mars, or what would I weigh on the moon, or what would I weigh on any object in space? They use this formula. Why? Because the universal constant never changes. Never changes. The forces that control our Earth are fine-tuned. Newton said this. He didn't have this number, but we know what gravity does. We know that gravity does many things, and we use it. We use it, fly spacecrafts around the Earth now. We know about gravity. We use it for diving and sports and all sorts of. You go to and have a ride, a roller coaster ride. You're going to use gravity. Gravity is a key thing. We know about the solar system and how these objects move around the sun because gravity is there. Now, according to Einstein and others, they talked about gravitational warp. That's a big thing. I'm not getting into that now, but I want to show you gravity, it's a controlling force that literally controls everything in the universe and as a constant. These constants never change. Look, these are the constants of electrons and protons. I want to read those small numbers to you. They never change. Guarantee it. Every equation you plug them in, they never change. Actually, there are 26 fundamental physical constants that address the particles and laws that define the interactions among the fine-tuned universe. There are many more, but they have defined 26 that possibly can keep this universe together. And I just took a few out for you. They never change. These constants never change. They're with us. And when you look at them, you see that there is very well fine-tuned. Even Dmitri Mendeleev came to the understanding that, hey, on Earth, the elements that I find, the things that I find, I can actually organize these fundamental elements from matter, taking these fundamental things, elements, and seeing that they have properties. And he put it in a table because these properties have similarities. So on Earth, we see these fine-tuned things working so we can apply them. We can use them. With this periodic table, we're able to discuss that, hey, there are certain things that react the same way. For instance, fluorine, chlorine, bromine, and iodine can form a gas. Heated iodine can form a gas. Bromine, just pouring, it forms a gas. And that gas, that element, the halogens, that family of elements literally can sanitize you, can burn your skin, can do all sorts of stuff. We use it to sanitize. We also use it for all sorts of things. So we know about these things because there's a regularity in what we see because the universe is well fine-tuned. The periodic table today, it has more elements now. This is kind of an older one I used when I taught chemistry, but it has a whole, I mean, there's so many things, one side metals, the other side non-metals. It goes on. I enjoyed teaching that. It's just a fabulous way of being able to see God at work. Now, Newton believed in an intelligent designer. When he looked at this fine-tuned universe, he didn't say Big Bang or this came from a cosmic accident. No, he said this. Newton believed that the universe and all things proceed from the counsel and dominion of an intelligent and powerful being. He felt that the supreme God exists necessarily by the same necessity as he exists always and everywhere. Newton understood that. And let me tell you something about Newton. He was a genius of his time. He wrote the Principia when he was young, and it gave us the physical laws. In our physics book, most of it is Newton's laws, teaching Newton and what Newton did. All the mechanics is developed by Newton that we use today. Newton single-handedly contributed more to the development of science than any other individual in history. Now, I want to throw Einstein and others, but he really gave us a foundation which we work. Now, I want to throw this in because we need to understand something. We need to understand that the fathers of science, what we call modern science today, gave us a method for investigating the world around us. And these were godly men, okay? When I talk about Kepler, I talk about Isaac Newton, which I just did, Francis Bacon, Robert Boyle. These were godly men. They got rid of the old Greek system using the deductive method and used another method, inductive, where they simply took out things, experimented with them, looked at the details, and looked around the world around them and started to experience it, see it, and touch it, and start looking at things and seeing if they could develop experiments to repeat things. That's how we developed the scientific method. Francis Bacon developed a scientific method to provide a new way to look at the world by asking questions and pursuing truth by inductive method. So Francis Bacon became the founder, and the rest, Galileo and Newton and Boyle followed him, okay? So he started the scientific method, and he was interested, believe it or not, he was interested in looking at everything around him and seeing if there were miracles, seeing if things around him, did that come from a miracle or what? So he experimented on it. He wanted to see if it was a miracle or if this was something here on Earth that we could see and we can observe. Was it natural? So making repeated observations, carefully and accurate observations. He developed the experimental method. It gives answers on high probability by doing things over and over again. This is what we call the modern scientific method. It was, yes, the fathers of modern science were godly men, very much like Newton, who understood that God was a creator and he fine-tuned the universe. Now, I want to show you something and share something with you that I think is very important, because when we study the idea of origins, how did we get here and where did everything come from? It's based on this kind of fundamental chart. And this is the scientific approach of evolution by Rob Stedler. Now, I'm going to be speaking a lot about Rob Stedler next time. He's got a good mind. He basically set this out so that we could look at what we call operational science and historical science. Now, operational science is something we work with. That's what I was talking about with the modern science. The fathers of modern science were operational. They did experiments. And so if you can repeat the experiment, you got good confidence level. That's what it's saying here. Confidence meaning that this is good, this will work, this might be true. Now, science is very interesting because science is comes to the truth, but never claims to be true. You know what I'm saying? You come close to it. You come close to it. You come close to it. That's the proper way of understanding science, because we are a finite minds. This is what the modern scientists, the inventors of modern science, the fathers of modern science taught us. Where to come close, where to go, because they understood that God was the perfect one. And everything that he did was perfect. So we would come close to try to understand him. Come close, come close. So if it's repeatable, you had high confidence level. If it's not repeatable, you didn't have a high confidence level. Now, I'm going to go through this quickly. Directly measurable. If you went through directly, if it was directly measurable, high confidence. If it was indirectly measured, okay, no, it's not high confidence. If you're not measuring it right, how do you know it's true? You see, okay? Then if it's perspective and the data is there, you can make some ideas of what to do in the future. You can study it. It becomes something you can really study. If it's retrospective, you kind of have to make things up a little bit. When you don't repeat, you can't make careful observations and avoid bias. If you can repeat things, but if you can't repeat things, guess what? You make many assumptions, and you you have great opportunities to be biased. So you less assumptions are made with operational science than you do with historical science. You're making lots and lots and lots of assumptions, and you make a sober judgment on results usually. Make sober judgments and results. So medicine, for instance, in the field of medicine, they do all sorts of studies. Why? Because they learn by their tests who reacts and how people react to medicine. So they have what they call high level of confidence if they get to a certain threshold. And that's what science is all about. That's what we call science. So when somebody says the science is behind you, you have to understand, you have to ask one basic question. Is it repeatable? If it's not repeatable, then you have low confidence. You follow me? Big Bang, is it repeatable? No. Is biological evolution repeatable? No. You just heard Dawkins speak about this remarkable molecule that just by chance, by luck, also Darwin. So what I want to do is take a quick break, and we have a film that we're going to offer. But I want to show you the beginning of the film, because when I wrote the director's letter that's coming out, I was so inspired by this film. I love this film. It's called Dismantling, and a theory of evolution. And the producer gave us permission to use the film. I've worked with him before, and so we're going to share this with you. I'm going to see if I can get it to where I want it, and let's see. Okay, are we all right, Johnny? Move this over here. Yeah, you tell me if we're getting it okay. So so this is called Dismantle. Let's start the film. It does Jason LaBrage is the producer, and he does a great job in introducing the concepts that I'm speaking to you about tonight. We're just going to do the introduction to the film, the first 7 minutes.
Have you ever looked up at the night sky and wondered how the vast expanse of the universe with its countless stars and galaxies came into existence? How do you explain the incredible diversity of plants and animals that fill our habitable planet? How old is the Earth? And how can we know for sure? And how do you explain the origin of mankind and the beautifully diverse ethnic groups? Put simply, Where did everything come from?
For centuries, we have struggled to understand where we came from. Many theories have been proposed, some rational and thought-provoking, others wildly speculative and seemingly impossible to verify. So how do we sort through all of these theories to determine which one is most logical? Modern science is revealing important clues to this puzzle, helping us to better understand the full picture of our origin. However, the mystery still remains. Where did everything come from?
The standard answer offered is the Big Bang explanation for the origin of the universe, and the evolutionary theory for the origin of the species. This means whether it was the formation of the universe, the first life forms, or people, the answer is the same. It was all the result of blind natural processes acting on matter and energy over many millions and even billions of years. As stated by National Geographic magazine, it all began in chaos. In other words, the universe and everything in it, including you and me, are nothing more than the sum total of a series of natural accidents. For the Big Bang theory, the universe formed through accidental collisions of atomic particles. For biological evolution, the species formed through accidental copying errors in the DNA called mutations. This is the story we've all been told. But what if the standard answer is not as convincing as we may have been led to believe? What if there are fundamental problems with the Big Bang and the evolutionary theory that scientists are well aware of, but have not been made known to the general public? In the last decade alone, compelling new evidences from the major fields of science have cast serious doubt on the evolutionary view of natural history. Discoveries so profound, if made known to the world, would have the power to drastically change our understanding of the past. Might the biblical view of origins as described in the book of Genesis offer a more reasonable explanation? To some, it is extremely naive to even consider the Genesis account of creation on the grounds that it is believed to be nothing more than a primitive myth, and therefore totally incompatible with modern science. This stems from the widely held perception that creation is religion and evolution is science. But is this really true? Is it proper to equate evolution with science? Does science have the ability to address questions regarding past events that we were not there to directly observe or verify? Events like the spontaneous origin of the universe, the origin of life from non-life, and the evolution of the earliest life forms into mammals. Or might we be giving science a power it does not have? To answer this, it is important that we accurately define science as well as its limitations. When we think of scientists in white lab coats analyzing cells under a microscope, or chemists mixing acids and bases, it is known as observational science. This is the type of science that led to finding cures for diseases and our advanced technology, computers, smartphones, orbiting satellites, and Mars rover robots. A good definition of observational science can be found in standard introductory level biology textbooks, which state, scientific inquiry is a powerful way to know nature, but there are limitations to the kinds of questions it can answer. These limits are set by science's requirements that hypotheses be testable and falsifiable, and that observations and experimental results be repeatable. Notice observational science has definable limitations to the kinds of questions it can answer. Hypotheses must be based on observations and experimentation. In addition, Hypotheses must be testable and their results repeatable. Observable, testable, and repeatable experimentation are the hallmarks of good observational science. When biologists grow bacteria on a nutrient medium to study adaptations, growth rate changes, or sequence their DNA to determine which genes suffered mutations. They're practicing good observational science. But answering the question of where bacteria came from to begin with, their origin, is outside the bounds of observational science.
Science really is about the study of the operation of the present world. And a lot of people think that, well, no, some science, you study the past. Well, not really. I mean, when you dig up a fossil, people say, see, there you go, you're looking at the past. Well, no, you're looking at the present. Fossils exist in the present. And that's not to say we can't make some guesses about the past based on some of the scientific evidence we see in the present. But our worldview, our way of thinking, our view of history will obviously influence any reconstructed past. Same goes with stars and galaxies. People say, you look at galaxy, you're looking back in time. Well, I'm looking at the galaxy today, right? The photons are hitting my eyes today. And so astronomy really takes place in the present. And granted, we can speculate about how galaxies looked, 1,000 years ago, or stars looked like thousands of years ago. But the fact is, those kind of claims are not scientifically testable. The kind of science that makes computers work and puts people on the moon, real science, observational science, is testable and repeatable in the present. It doesn't take place in the past, it takes place now.
So I wanted you to understand this is basically where I want to go now, so we can see it. There we go. So let me just move some things over here. Okay, so yeah, I wanted you to see that. I love that film. What really got me was when they talked about the fact that it was an accident, and that I fell for this when I was in college. And so many students don't understand, when they say an accident, this is not scientific. If it's a one-time kind of thing, it's not really operational science, they call it, or they called it observational science, operational observational, same thing. So that's what I wanted you to see. Now, as we look at this, now let me see if I got my sequencing right. Let's see. Here we go. I want to focus on faith, because basically that's where the fight is. If you look at the controversy, it's people who have faith, that have trust in something, and there are people who have trust in something else. You follow me? So that's the controversy. Where do we come from? How do we get here? So I want to focus on that for a moment. Now, Merriam-Webster gives us a couple of definitions of faith. I thought I'd share them with you. Allegiance to a duty or a person. Another definition of faith is belief and trust and loyalty to God. Another faith definition could be complete trust in something or someone, like having a faith in your spouse or something to that nature, faith in a friend, and so on. So that's what we're talking about by faith in a more common sense. In the Bible, it's more specific. You see, we know that in Hebrews 11:1, it says, it gives us a definition of faith. Now, faith is the substance of things hoped for, the evidence of things not seen. So we have a hope. You see, we have a hope in things that we cannot see. But I want to tell you something. God is not illogical. You're going to have faith in things that are logical because God is logical. God is, by his very being, is rational and logical. So, and without faith, it is impossible to place God, because anyone who comes to him must believe that he exists and that he rewards those who earnestly seek him. Hebrews 11:6. So we have faith in God because we know he's there, and he has, if he's there, he's almighty, all powerful, and he will give us eternal hope. We know that. We go on and we see that Jesus replied, because you have so little faith, truly I tell you, if you have faith as small as a mustard seed, you can say to the mountain, move from here to there, and it will. And move, nothing will be impossible for you. And so when we look at that, I mean, God has demonstrated through his teaching that if you have faith, anything is possible. With me, not dream, dreams will come true. You've heard that saying, dreams will come true. Think of, and it'll come to be. That's not what we're talking about. It's talking about a faith and presence in God. That's what we're talking about. Faith comes from hearing, and hearing from the word of God. We hear. We were able to see God's word. God's word is so important. The beginning was the word is with God, John 1:1. So we know that God's word is essential for our faith. Romans 1:20 clarifies this a little bit, because we're able to see through God's creation his invisible characters. For by Romans 1:20 says, for the invisible things of him from the creation of the world are clearly seen, being understood by things that are made, even his eternal power and Godhead, so they are without excuse. The fact is that God has become visible because he created this universe so we could see him. And that to me is the best thing possible. I mean, the fact that he walked on this earth so we can experience him. We're told about him in the Old Testament. And then he comes true. He actually comes true in the New Testament. He's walking, he's speaking, and he's dying. Eventually becomes the bloody sacrifice for our sins that they talk about in the Old Testament. So we're able to experience it. And that's the neat thing, because science talks about observations, about experiencing, and so on. So I know this is a godly thing to do science, because we're experiencing God when we do it. We experience his characteristics. We experience him. We see what it's all about. That's why science cannot be taught without God. We go and we take a look, and we see that in Psalm 19:1-4. I love dead King David. He's got this way about him that declares God's glory in so many neat ways. The heavens declare the glory of God, the glory of God. The skies proclaim the work of his hands. Day after night they pour forth speech. Night after night they display knowledge. There is no speech or language where their voice is not heard. The voice goes out into all the earth, the words to the ends of the world. Looking at the stars, God is telling us he is God. Looking at the unbelievable pattern, we're going to go into this a little bit. You can't deny that there's a God, because as we study the stars, as we study the cosmos, we see the work of God's hands everywhere. I love this verse. Isaiah 40:26 says, lift your eyes and look to the heavens. And who created all these? He who brings out the starry host one by one and calls them each by name because of his great power and mighty strength. God has numbered all those stars and he's called them out. Not one is missing. That's what the scripture says. So as we look at God's creation, his unbelievable precision and his clockwork, we see God's handiwork everywhere. We look at the Milky Way galaxy. It's a spiral galaxy. It's a shadow of the Milky Way galaxy. It's composed of 200 billion stars. Now, if you were to count the stars, 3 stars in a second, 1, 2, 3, 1, and go like that, it would take you 84,000 years to count the number of stars in the Milky Way galaxy. 84,000 years. That's a lot of time. We look at this is the Horseshoe Nebula up in taking pictures. It's beautiful. The God's glory in heavens. We see heavens emit light. The heavenly bodies emit light and other radiant energies through great distances. Light can travel through all these distances. That's another big mystery. And we see that these are several hundred million galaxies. There are several hundred million galaxies. The total number in stars estimated to be septillion or trillion stars, and the number keeps getting bigger. We've actually looked at the universe and did some estimates. And so septillion comes to my mind. It's 10 to the 24th trillion. But that number keeps growing. The more we observe in deep space, the more we were able to see more and more stars. Now, using our latest technology in computer science, we can count 10 million stars in a second. Even with the technology at hand, it would take 30 million years to count all the stars in the universe. And we're still increasing numbers. So we've got a problem there. Our nearest neighbor is Alpha Centauri. It's a star, 4.3 years, which is 25.5 trillion miles away. I like to put in perspective in things that you can, miles, not light years. I like to talk miles, okay? That's the closest star, Alpha Centauri. The light year is equal to the distance, that's equivalent to 6,024 trillion, okay, 6.4 trillion miles away, anyway. Big distances from star to star. And we see the stars all together, galaxies. Come on, the number of the universe estimated to be 420,000. The space, now we're talking about space, is 42,000 trillion miles of space, just space. I mean, it's vacuum of space. There's hardly anything in there, but it's so much space. So we know it's big. We know that God, he's infinite, without limits, without boundaries, endless, countless, and the number infinity comes to my mind. Infinity, meaning that it approaches infinity. Just like science tries to approach the truth, we look at the stars and say, look at that. It's like, I can't count anymore. God is so big. He determines the number of stars and calls them each by name. God is the Lord and mighty in power and understanding that has no limits in Psalm 147:4-5. God is literally calls each star by its name, as we said earlier. Not one is missing. That's our God. Now, when you look at the Big Bang cosmology, they talk about this big explosion starting, and it spreads throughout the universe, and it takes about 13.8 billion years. And they talk about, they have like stages. And so the first stage and seconds, you see the birth of subatomic particles, and then you see electrons and nuclei, and you go up, and eventually you get you somewhere around here. Now, yeah, I mean, that's what we're talking about, the idea of this idea of expansion. I want to go through with you just a little bit about this kind of idea. And I don't want to spend a lot of time because I think you'll get it right in the beginning, especially when we talk about these complex concepts. The idea of singularity. What is it? Well, matter and energy, space is compressed to many millions of times smaller than a proton, a cosmic seed, and exploded an undetermined reason continues to spread out today. So that's what they're talking about. Now, I want to show you something. This is an event horizon, and inside there's a black hole. Now, they talk about singularity here because they think that everything is brought in there. Gravity just sucks it in, including light. And this distortion, believe it or not, of time. So much so that it was Hawkins that said that God couldn't create anything because there was no time. Because he believed that the whole universe at this moment of singularity were all sucked in this big hole and there was no time whatsoever. Now, there is, of course, something wrong with the concept because here we see black holes and we know that light's going in there. But this singularity is much different than the singularity we're talking about black holes. We're talking about something that has never been experienced ever before. And we know that if it has happened, it has happened, it's been observed before. It's never been observed before. So we see this idea that this event horizon can be observed, but this has never been observed before. So we see who stretches out the heavens like a curtain and spreads them out like a tent to dwell in it, Isaiah 40:22. The universe is expanding and moving closer and closer to infinity. Such knowledge is too wonderful for me. I cannot, it's high, it is high. I cannot attain it. This is Psalm 139:6, David. So as we look at the Big Bang, we see that the Big Bang started at 10 to the minus 43rd seconds. That's what we call Planck's constant. What is that? Well, that is when we try to break down atoms and get the basic concepts and everything. So they have hypothetically made this time zone by using physical constants. But again, this is something that's very hypothetical, as I said. we never observe singularity. Singularity has never been observed before. So let's take a look at it. From 10 to the minus 34 to 10 to the minus 34th second, 43rd to the 43rd second, in that time span, and we had a second Big Bang. We had a first one that started to explode energy, but the second one had to be more horrendous than the first. Because remember that the whole universe is dynamic. As I mentioned earlier, we're moving at speeds, it's moving out. So they're moving at tremendous speeds apart. Presently, there are numerous theories because the energies needed is missing. So this whole idea in this area called inflation, in this area, right in the beginning of the Big Bang, right after the first bang. Now there's going to be a second bang. The first bang opened things up and released energy. Now we have this kind of energy where things have to be released again because we have to move out, way out in space. Things have to move from one point all the way out, as we showed you, the 42,000 trillion miles out of the mileage space we have. Everything has to move out that way. So we can see it that way from that point of view. Now, a cosmologist did some work, and he actually, creation cosmologist, said, okay, let's figure out what this velocity would need to be, this kind of second kind of velocity or explosion that we would need to expand the universe the way it is. So he took this pen and did some mathematics. So he made this example about atomic bomb used in Hiroshima, a blast velocity 280 meters per second. In other words, when that thing exploded, when that bomb exploded, it moved out and moved out very quickly. People died because of the impact, because of the noise, being sucked right in the vacuum, so much power, and moving so quickly outward would cause tremendous amount of destruction. So the inflation velocity, according to the calculation for this event horizon to take place, or the fact that they would have to go through a second explosion called inflation, would have to be 50 orders of power, which comes out to this number right here. I'm not going to even try to, it has 17 zeros. I mean, 17, it's more than 17, it's 21 zeros, close to 21 zeros, 21 places. That's how much power you would need, more than a Hiroshima bomb. Now, that's ridiculous. That is utterly ridiculous. Where can you get that amount of energy? I mean, this is all speculation. And when we look at this, there's something missing. You see, when we look at this expansion of the universe and we see the mechanisms in which these galaxies move and stars move, something is missing. It's called energy and matter. And so they call it, because it's missing, we don't have it, they call it dark matter and energy. Dark matter, there's a theoretical invisible matter, occupies 25% of the universe. You can't see it. It's in clumps. It anchors the galaxies and galaxy clusters. I'm going to show you one in a second. Dark energy, theoretical energy spread throughout space. The energy needed to go through the whole space. Do we have it anywhere? No. It's nowhere observable. So what do they call it? Dark energy, responsible for the Big Bang, accelerating expansion of the universe. Embarrassing to the cosmologists, the dark stuff occupies 94% of the universe, while only 5% is visible. Take a look at this beautiful galaxy, spiral galaxy, a whirlpool galaxy in winding arms, and you could see it as it's spiraling out. Spiraling, we call it spiraling staircase. Though the inside of this is moving faster than the outside. So you have to use tremendous amount of energy to keep this thing going all the time. So you need energy from outside. So they've estimated, astronomers speculate, the Milky Way galaxy is shredded by a haze of dark matter particles 10 times as massive as the disk, and nearly 10 times as big in diameter. So they kind of artistically put this kind of dark matter inside of it. We can't see it. They just imagined it. So we see that when we talk about Big Bang, there's all sorts of problems. At such places, physics dissolves into metaphysics. These mathematical points emit no explanation, that they just are. Roughly 50 forms of inflation have been proposed. It's more than that now. Named and studied, including double, triple, hybrid, and inflational tidal hybrid, inflational hybrid, extended inflation that is warm, soft, Tibet, and natural. It goes on and on and on. The study of origins of the art of drawing sufficient conclusions from insufficient evidence. I like that quote because that's really what we're dealing with. So remember, our modern fathers of science, men of God, have given us a model for science, basically an operational one. And so when we looking back in time, we see confidence levels going down. I believe it says in Genesis 16:18 on the fourth day, there was a creation of the universe, and God made the two great lights, the greater light to rule the day and the lesser light to rule the night, and the stars. I like how we said, and the stars. By the way, we created the stars too. And the last set of them in the explorer, and God said, let them expand, let them in the expanse of heavens to give light, the earth, to give light on the earth, to rule over the day and over the night, and to separate the light from the darkness. And God saw it was good. The light can be seen everywhere, as read in Psalm 1 to 4. We see God's speaking to us in his glory as we look at the stars. We see God's radiance coming through that light. Hebrews 11:3 says, by faith we understand that the universe was formed at God's command, so that what is seen was not made out of what was visible. Colossians 1:16 says, for in him all things were created, things in heaven, on earth, visible and invisible, thrones, powers, or rulers or authorities, all things have been created through him and for him. That's why I believe that God is part of all of this. I believe that we got everything wrong, especially in the schools today when they define science without God. Because without God, there's no science. We have men of science who develop operational science who are trying to find truth around the world, or come close to truth, to see that there is a God, that God, invisible God, has left his fingerprints everywhere. So we see that. And as I close, I'd like to share this video with you, Dismantle. You saw the beginning of it. This is an excellent tool. I love this tool. And I've been given permission to share it with you guys. And I want to continue to talk about it. This really got me motivated because I don't know if you noticed, the student in the beginning was asking questions, or she was a high school, college student, involved with what's going on today in the universities. And you get a chance to see the discussions and the rationale that goes behind it. God is an unbelievable creator, and he's left nothing unturned for us to see and to establish that we know him and establish him. So